Objects are a concept common to most modern programming languages. At their core, objects are groupings of behavior and data. Objects give us a way to pass around a group of variables and associate that group with functions who always have access to those variables when they run. Objects often, but not always, represent real-world things. A classic example is a person object that can hold variables representing their name, address, age, etc. We could, for example, have an object that represents our robot. Maybe its member variables keep track of its position, and it has a member function that lets us ask the robot to move to a new position. These members are tied together. The moveTo function needs to have access to the x and y member variables to do what it does. An important thing to note is that you can have multiple instances of the same type of object. If we have two robots, for example, calling moveTo on robot 1 does not change the member variables of robot 2. These two instances are separate objects. We define the structure of objects using a class in our code. This is something we'll look at how to write later on in the training. For now, we just need to know that we can have multiple objects, all of the same class, moving around in our code. In C++, accessing members of an object, both variables and functions, is done with the dot symbol. The name on the left of the dot should be the variable name of some instance, and the name on the right of the dot should be the member name. This example shows us declaring a new variable named p1, and getting the name of this person with the line p1.name. If you're wondering about the way we're initializing this p1 variable, we're using something called a constructor. Constructors are special member functions that initialize an instance of our class using some set of input parameters. In this case, we can guess that our person class has a constructor that can fully initialize the person object with just a name and an age. There's another type of special member function called a destructor, which handles cleaning up an object when we're done with it. This is useful when our objects hold some external resource. We might have a file object, for example, that holds onto a handle it got from our operating system. It needs to tell our operating system when it's done with that handle, and that can be done in the destructor of the file object. Constructors and destructors are another thing we'll look at in more detail later on. The important thing for now is that we recognize that when we're initializing a variable with a class type, we're calling that special constructor function. And when the scope of our variable ends, its destructor will be called so it can clean itself up. One final note for this video. C++ is not an object-oriented programming language. While objects are used extensively in most C++ code, not everything in C++ is an object. C++ is a general language that can support a variety of different programming paradigms. You can certainly write object-oriented C++ code if you want, though the best projects will use the strengths of all of the different styles possible in C++.